In this tutorial, I am going to discuss a very interesting problem known as flood fill. So the problem statement is an image is represented by a 2D array of integers. So imagine this is an image which is represented in the form of 2D array of integers, and each integer representing the pixel value of the image. So each integer representing the pixel value. Given a coordinate, so given a coordinate representing the starting pixel of the flood fill and a new color. Flood fill the image with new color, and to perform a flood fill, consider the starting pixel plus any pixels connected 4 directionally to the starting pixel of the same color, and we have to write a code to replace color of the given pixel and all adjacent same color pixel with the given new color, and at the end return the modified image. So now let's take an example to understand this problem statement better. So in the first example, given this 2D array and a coordinate, so the coordinate is first row and first column. So this is the first row and first column, and the color is 1. So we have to replace all the colors, all the pixel whose color is 1 with the new color which is 2, and we can move upward direction, downward direction, right direction, and in left direction. So let's replace this with new color. Then we can move upward, replace this with new color. Then we can move left, replace them with new color, and left, let's replace them with new color. Move downward, replace with this new color, and move right and replace them with the new color. So we can't reach at this point. So if we go in, let's say, right directions, so this is different color, so we don't have to fill this pixel. Similarly, if we go downward direction, we don't have to fill this color, and we can't move diagonally, so there is no way to reach at this pixel. So at the end we return this image. And now let's see the second example. So in the second example, so the coordinate is second row and first column. So second row and first column is this one. So it is 0, 1 and 2, 0, 1 and 2. So this represents the row, and this represents the column. So second row and first column, and the new color value is 1. So the current color value is 1 and the new color value is also 1. So we don't have to flood fill this image. So it is already, it is already filled with the same color. So we return this image as it is. So this is the problem statement. And now let's discuss how we can solve this problem. Let's discuss how we can solve this problem. So in this example, I am going to use depth first search to solve this problem. So the idea here is to first find the pixel color present at the given coordinate value, and if it is different from the new color value, then recursively fill the current pixel and all the neighboring pixels with the new color. So given this 2D matrix, and we have given the coordinates. So the coordinate is first row, first column. So the color present at this pixel is 1, and it is different from this new color 2. So what we have to do is we have to fill all the pixels whose color is 1 with the new color value which is 2, and to fill all the pixels, we can move in 4 directions. We can move upward, we can move downward, we can move right, and we can move left. So the first step is to get the color present at this coordinate, and we get the color which is 1. Now the next step is to compare this color with the new color. If it is different, it means we have to call this method which recursively fill the new color with in all the pixels whose value is 1. And if the color and the new color is same, then simply return this image. If the color present at the coordinate is different from the new color, then we have to call this method, and in this method we are passing following arguments. First, reference of this 2D matrix, then the starting coordinates, so I and jth index, so ith row and jth column, then the new color and the color present at this this coordinate. And in this method we have to start filling the pixel. So we have to pass the value of this starting coordinate, as we have to start filling this image from this index, and we can only move in 4 directions. So here is the code. We are recursively calling this method for I plus 1, for I minus 1, for j plus 1, and for j minus 1. And this is the base condition, and here any of the condition is failed, then we simply return from the call stack. So the condition is, if the value of I and j is less than 0, if the value of I is greater than row dot length greater than or equal to row dot length, or the value of j is greater than equal to column dot length, and the current pixel color is not equal to the color which is present at the coordinate. So if any of the condition is failed, then we simply return from this method. Else what we do is, initially we pass this coordinate 1 1 and this 2D so the reference of this matrix, 2D matrix, then the new color and the color. So initially, so when we call this method, so we reach at this statement and we fill this pixel with the new color. Then we reach at this statement and we move to I plus 1. So we move, so the column remains same and we move to next row. So when we move to next row, the value is 0. So when we check this condition, so this condition is not satisfied, we return from this call stack. So again we reach at this statement and then we execute this statement. So where we move to the previous row, so we move to this row and the column is same. So here the value is 1. So what we do is we fill the new color. So we fill the new color and again we recursively call, and in this time the row value is -1, so which is less than 0. So this condition fails and we return from this function call, and again we reach at this statement and then we execute this method, and so this time the row remains same and we move in right direction. We increment the value of j, so we reach at this pixel and we see the color is 1. So we have to fill this new color. So we fill this new color and then again we recursively call with j plus 1. So this time, so the value of j is greater than the column dot length. So this condition fails and we again reach at this statement. So in this way we fill all these pixels with the new color and we can't reach at this cell. So we don't fill this cell, and after doing all the operations we return the image. So the image is this one. So in this way we solve this problem. In this way we flood fill this image. So now let's talk about its time and space complexity. So its time complexity is on and its space complexity is also on. So we are calling recursively. So we are filling this complete 2D so this matrix, this 2D matrix recursively, and in worst case we have to fill all these cells. So, and in recursive call we have to maintain the call stacks. So that's why the space complexity is also on. So that's it for this video tutorial. For more such programming videos, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.